Hey everyone, and welcome back. Now in this video, we're going to dive into lung pressure and understand how air actually moves in and out of your lungs. We'll also talk about something called negative pressure, and I'll show you how these pressures keep your lungs open and what happens when things go wrong, like in diseases called pneumothorax. Let's make it simple and connect it to real life. Why does air move? So here is the big idea. Air always moves from high pressure to low pressure. That's it. That is the rule. If pressure inside your lungs is lower than outside, air flows in. If the pressure inside is higher, air flows out. And this concept isn't just for air, it's how everything in the body moves. Let me give you a simple example. Perfume. Imagine you spray perfume in one corner of the room. At first, the smell is very strong in that area, high concentration. But after a minute or two, the smell spreads across the whole room. Why? Because particles always move from where there is more to where there is less, until everything evens out. That's the same with air, and it's the same with gases like oxygen and CO2. It's called gradient, and the body uses it all the time. Now let's talk about lung pressures. There are three main pressures you need to know. First, atmospheric pressure. This is the pressure of the air around us, the air in the environment. We set it to 0 to make math easy. Second pressure is the alveolar pressure. You remember we talked about it in the first video, the alveolar sac, and these small cells where the gas exchange happens. This is the pressure inside the alveoli, the tiny air sacs in your lungs. When alveolar pressure is lower than atmospheric pressure, which is the pressure outside your body, air flows in. When alveolar pressure is higher than atmospheric pressure, air flows out. Now let's talk about the third important pressure that you need to know. You remember we talked about the intrapleural space, which is the space between the two membranes around your lungs, the visceral pleura and the parietal pleura. This is the pressure in the pleural space. The pressure there is always negative, usually around -4. It's like a gentle suction that keeps the lung expanded. What does negative pressure means? Negative does not mean bad. It just means that pressure is less than 0, less than atmospheric pressure. Think of it as like a vacuum, and what it does, it pulls things in. That's what your intrapleural space does. It creates a vacuum that gently pulls your lungs open and keeps them from collapsing. Now, why does this matter? Because that negative pressure is what holds your lung open between breaths, even where you're not doing anything. Let's imagine it. Picture a balloon inside a sealed box. The balloon is your lung, the box is your chest wall. The space between them has a vacuum, negative pressure. Now, if air enters that space, the pressure is no longer negative. It becomes 0 or even positive. What happens? The balloon collapses, your lung collapses. Pneumothorax means air leaked into the pleural space, the space that's supposed to be a vacuum. That vacuum is gone, the pressure is no longer negative, and the lung collapses. That's why a patient with pneumothorax might feel chest pain and shortness of breath, and you can hear reduced breath sounds on that side. This is one of the most common and clearest examples of why understanding pressure is important, not just for physiology, but for real clinical practice. And that's it for this video. Now you understand how pressure differences control air movement and how the body moves and uses negative pressure to keep the lung safe and working. In the next video, we will build on this and talk about lung volumes and surface tension and how different diseases affect how easily the lungs expand or collapse. Thanks for watching, and don't forget to breathe deeply. You've got this.